Hi guys, welcome to the next part of power electronics. So we are solving problems on inverters. Let us start continuing this. So already we have been solved so many questions. I hope you all have understood whatever we did in the past, right? So let us continue from there. I think in the last class I had given some homework question. I think yes, this is the question, right? May I know what is the answer for this question? I'm giving 2 more minutes. Just drop the answer for this question. I had given this one as the homework, right, in the last session. What can be the expected answer for this question? Do it fast and drop your answer in the comment section. Just take your own time, no issues. I'm just expecting the answer. Okay. Geeta. I naught 1 is 69.77 ampere. Good. I naught 1 means fundamental current. Very good. What about the third harmonic? Anyone? Chalo. Let us try to solve this question. 1 minute. Yes. See, basically, what is the given data and what we are trying to ask? Let us collect the data. Then I will try to solve step by step. A single phase full bridge inverter is having a supply voltage is 200, okay, and it is connected with the RLC load. The value of R is given as 2 ohm, XL is 3 ohm, XC is given as 2 ohm again. And the output voltage is controlled by pulse width modulation technique. We know whenever we are hearing this word pulse width modulation technique, immediately what we have to write? I told you the output formula. There are two formula. One is the trigonometric Fourier series expansion. We know what is the trigonometric Fourier series expansion, that can be written as 4Vs upon n pi into sine n pi by 2 into sine n times of d into sine n omega t minus n into phi. And there is one more formula also. What is that? Normal output RMS formula. What is the formula? That is supply voltage into 2d by pi whole power 1 by 2. That's all. I told you just to remember these two formulas only. And this is output formula. And I also explained how this formula came. So you don't need to memorize. You can directly write this one. Anyway, let us continue the given data. Pulse width modulation technique they are using. So its correspondent output expression I wrote here. And they told that, sir, pulse width is 120 degree. What they are trying to mean? Always remember, pulse width means they are trying to talk about the width of the pulse. Then how will you write that one? Width of the pulse can be written as 2 times of distance d. And they haven't mentioned that how many pulses that they are considering here. By default, if they won't given any number of pulses, then you can treat that given if a pulse is only one pulse out of 180 degree. So this 2d can be directly equivalent to 120 degree. From this you can calculate the value of d. D equal to what? 120 by 2. I have to pass the 2 to the right side such that the value of d will become 60 degree. It is in degree only, right? Yes, sir. So we found the value of d also. Now what they are asking is the RMS value of fundamental and third harmonic current values are dash. Okay, sir. See, we know only voltage, but our basic common sense tells us, according to network theorem, we studied so many things in circuit theory or network analysis. Sir, impedance data is clearly given at the output side, output voltage also given. So, in the output side, they are connecting one resistor and there is an inductor and there is a capacitor. Everything is connected and they had clearly given the data about it. They told that the value of resistance is 2 ohm and the value of inductive reactance XL equal to 3 ohm and the value of capacitive reactance XC equal to 2 ohm. It is fixed. They told. Right, sir. From this, how will you write down the total impedance, output total impedance? That can be written as real part resistor plus inductive reactance can be written as J times of XL. Capacitive reactance can be written as minus J times of XC. We all know that. So if I will substitute the value of R, that will be 2 plus J times of XL, that is 3 ohm, minus J times of XC, that is 2 ohm. So this can be further written as 2 plus, see, 3 times of J minus 2 times of J will be resultant, J only. So the overall impedance Z will become 2 plus J ohm. It is in rectangular domain. So now what I am going to do is further I just wanted to write this expression in polar domain. You know this expression in rectangular form. How will you convert it into polar form? That is also we did in network analysis. If you want to convert this into polar form, then we have to find out the magnitude of the impedance and the corresponding phase angle of the impedance. You know how to convert the magnitude. Under root of square of real part plus square of imaginary part. What is the square of imaginary part? Here the coefficient of j is 1. Coefficient of j is imaginary part. And at an angle, how will you write? That can be written as tan inverse of imaginary by real. Imaginary is 1, real is 2. So tan inverse of 1 by 2 is the phase angle. Now, if you calculate 2 square plus 1 square, 2 square will be 4 plus 1 will be 5. If you take square 5, root of 5 will be 2.236. That is normal value. And we have to take 0.5. 1 by 2 means 0.5. Tan inverse of 0.5 will be 26.56 degree. 26.565 degree. Yes, sir. I found the impedance clearly. Now, our common sense, sir, they are talking about fundamental current and third harmonic current. And how can I express these values? See, let me tell you, even this impedance also I have written it for only fundamental. First waveform, fundamental waveform, n equal to 1. We know this impedance also can be written. First, let me talk about nth harmonic. When we are discussing about nth harmonic, how should I write the expression in general way? Let me write. First, we know how to write the voltage expression for nth harmonic. How will you write? Summation, repeat, 4Vs by n pi into sine n pi by 2 into sine n times of d into sine n omega t minus n into phi. Yes sir, this is nth order harmonic expression for output voltage V naught of t. Similarly, if you want to write the expression for impedance with the nth harmonic impedance, see, the value of resistance will not change with respect to harmonics. But here, basically, harmonics will be dealing with the frequencies. We also know when we are discussing about third harmonic, then output waveform will become 3 times of actual waveform. So frequency will be tripled. If fundamental harmonic is 50 Hz, then third harmonic will be 150 Hz. So frequency will be keep on changing when we are changing the harmonic value, when harmonic will be changed, yes or no? So basically these harmonics are directly affecting the frequency. And we know, see, let me write somewhere here. XL can be generally written as, I am writing magnitude alone, omega L, and XC can be written as 1 upon omega C. Of course, there is minus j in front of this. I'm just considering the magnitude. So these things will come. Basically, this is for only fundamental frequency, first frequency, n equal to 1. This is also for first frequency only. Suppose if I am considering nth order, then what will happen? Omega is basically written as 2 pi f. So it is dealing with the frequency only. For nth order harmonic, the frequency will be multiplied by the number of harmonics. So wherever you have frequency, that will be multiplied by the number of harmonics. So this impedance can be generally written as R plus J times of n times of omega L minus J times of 1 upon n times of omega C. So let me write it further. So nth order harmonic impedance can be written as R plus J times of n into XL minus, I have taken J outside, minus 1 upon n into XC. So this is the general way of writing the expression for nth order harmonic impedance. Sir, now everything is fine. How can I write the expression for nth order harmonic output current? That can be, see, according to Ohm's law, I can simply write I is equal to what? V upon Z. This is simple Ohm's law. Just to substitute it. We know the expression for voltage. We also know the expression for nth order harmonic. So simply just to take the voltage expression 4Vs by n pi, and it will be multiplied by Zn into sine n pi by 2. Just it will be continuous further. Sine n pi by 2 into sine n times of d into sine n times of omega t minus sine n times of pi. Do you remember we have calculated this pi also? Yes. For our question, this pi has been calculated for fundamental. We have what we saw, that is impedance angle 26.565 degree. Okay, sir. That is only for fundamental. Anyway, this is generalized expression for the current. We did successfully next one also. Yes, sir. So our next one. Now fundamental current. I naught of 1. Fundamental current. This is what we need now. Yes, sir. We need fundamental current only. And they also told that we need fundamental RMS current. How do I do this? Now see there. This is fundamental only. Sorry. This is nth order harmonic maximum current. Then nth order harmonic RMS current means I have to divide this whole value by root 2. Yes or no? Such that the fundamental RMS current will become. First I have to replace n by 1. Then you have to divide this whole expression by root 2 to obtain the fundamental RMS current. So this value will become 4 Vs by n will be replaced by 1 because we are talking about fundamental. N will be replaced by 1. So n pi Z n will become Z1, and we also going to divide it by root 2. Then sine of n pi by 2, n will be 1, it will become only pi by 2 into sine of n times of d, it will become only d because n equal to 1. Anyway, only RMS current we are considering, this is sufficient. Now you all know this 4 can be rewritten as usual 2 into 2. 2 can be rewritten as root 2 into root 2. 1 root 2 will get cancelled with this one. So resultant it can be written as 2 into root 2 upon pi into Z1. Sine pi by 2 will be equal to 1. So it will be simply sine times of d. This is the expression for fundamental RMS current. Sir, what is the value of D here? Sorry, supply voltage Vs I missed. Now let us go back and collect the data. From the question, already they clearly told the value of D. The displacement angle is 60 degree. Yes, sir. And input supply voltage clearly given as 200. So we have taken these two data from here. Supply voltage is going to be 200. You can substitute and the value of D equal to 60 degree. Yes or no? Yes, sir. We all know what is the value of sine 60? Root 3 by 2. So let us substitute all the values here. So 2 into root 2 into 200 upon pi into, wait, Z1 also we will substitute now, into sine 60, that is root 3 by 2. Everything is fine now. So impedance Z1 alone is not known now. We know that value, go back. The value of fundamental impedance, that is 2.236. See, I have just considered this impedance directly without considering any harmonic effect. Here actually I am assuming that the value of n equal to 1, that is fundamental only. So directly we can take this 2.236 and you can substitute here 2.236. What can be expected answer now? First take 2 multiplied by 200, you will be getting 400. Then multiplied by root 2. Then you have to multiply it by root 3. Then divided by pi. Again divided by 2.236. Then again divided by 2. One more 2. So I am getting the overall value here. What I am getting is 69.74 ampere. Very good. Already Geeta did, right? Good. Guys, similarly we have to do third order harmonic. How can I do that, sir? So in order to do the third order harmonics, let us involve into this. First step is we have to express the expression voltage. How will you express? When you are replacing n equal to 3, V0 3 third order harmonics and RMS voltage I need. So RMS voltage means 2 into root 2 by pi will come. Just remember here, go to this expression. When I am dividing it by root 2, you know how it will change. It will become 2 into root 2 Vs by pi. Next, this n, wherever we have n will be replaced by 3 now. So, wherever we have n, it will be replaced by 3 into sine n pi by 2. N will become 3. So, it will be 3 pi by 2 into sine n times of d. N is what? 3. So, 3 times of d. Now supply voltage again I missed. Now let us substitute all the values. Anyway, the value of sine 3 pi by 2 is equal to -1. Just consider the magnitude. Anyway, that is going to be 1 only. Under the value of D, the value of D we know that is 60 degree. Yes or no? 3 times of 60 degree will become 180 degree. Anyone, can you please tell me what is the value of sine 180 degree? Sine 180 degree will be equal to 0, sir. So this whole factor will become 0. 0 into whole thing will become 0 only. So the value of third harmonic voltage will be 0. They adjusted or they fixed the displacement angle in such a way that it is eliminating the third harmonic effect. So you no need to consider this value, it is going to be 0. See, when third harmonic voltage will become 0, automatically third harmonic current also will become 0, because according to Ohm's law, current will become equal to what? Third harmonic voltage divided by third harmonic impedance. When third harmonic voltage itself it is 0, 0 by third harmonic impedance will be equal to 0 only. Anyway, for your understanding, suppose if you are getting any value, any finite value for this third harmonic voltage, how can I express this current, sir? For that, it is very important to know the value of third harmonic impedance. How will you calculate? We know R plus J times of 3 times of XL minus 1 upon 1 by 3 times of XC. Can I write like this? Remember one thing. Basically, how this expression can be written is nth order harmonic equal to R plus 1 time J times of n times of omega L minus 1 upon n times of omega C. Here, how will you rewrite this? R plus J times of n times of omega L can be replaced by XL. 1 by n times of 1 by omega C can be replaced by XC. It should be written like this. Did I write correctly here? 1 minute. No, see there, I made a mistake here. Forgive me. Xc equal to what? Xc can be written as 1 upon omega c, not 1 by xc. That is wrong. Correct it. Okay. Fine, sir. So this is how we are writing the expression. So now the value of xc, xl both we know. I think that is 3, 2, right? Let me check it once. What is the value of it is here 2, 3, 2. Now how will you write this? 2 plus j times of 3 times of 3 minus 1 by 3 times of 2. That is how we are identifying the impedance with respect to third harmonic. J times of 3 times of 3 will be 9 minus 2 by 3. 2 by 3 means you all know that is 0.6666. Okay. Now, if you subtract 0.666 from 9, you will be getting 8.34 approximately. 2 plus j times of 8.34. So this is the impedance of third harmonic. This is in rectangular form and you all know how to convert it into polar form if it is required. Anyway, for our question, this calculation is not required. Why? Because already our current is 0. We found the answer. But I just showed you how to do this. Don't blindly do the calculation. Okay, it's very important to estimate how these values are being evaluated. Okay. I hope you all understood this. We are happily moving on to the next question now. Sure. Let us take the next one. The question is a single phase. Uh, 1 minute, guys. A single phase full bridge inverter, as usual, full bridge inverter. A single phase full bridge inverter, as usual, is supplying RLC load. Supplying RLC load is connected with the RLC load. You can write is connected with the RLC load, whereas the value of R is given as 5 ohm and the value of XL is given as 10 ohm. Fine. Now what happens is the bridge operates with a periodicity of 0.2 milliseconds. The bridge operates with the periodicity of 0.2 millisecond. Okay, sir. The circuit turn off time required for the transistor TC, circuit turn off time required for the transistor, they given is 24 microseconds. Circuit turn off time for the transistor. For the transistor, circuit turn off time is given as 24 microseconds. The suitable value of C, find the value of C in resultant that the circuit will be in load commutation. What can be the expected value of C such that the resultant commutation will be in load commutation? Expected value of C such that the resultant commutation will be in load commutation. Can you try it once? A single phase full bridge inverter is given. It is RLC load. Inductive reactance is given, resistor is given, and they told something the bridge operates with the periodicity of 0.2 millisecond. Circuit turn off time is given as 24 microseconds. Then in order to operate the circuit at load commutation, what can be the expected value of C? That's all. I think already we haven't solved any question. I just இந்த மாதிரி மாடலை நம்ம சால்வ் பண்ணிருக்கோம்னு நினைக்கிறேன். Anyway, you can just have a try. Take your time. Let me set it. Got it? Anyone? Are you guys trying? Take 1 more minute also, but try to drop the answer. Okay, I hope I have given sufficient time. Shall I try now? Let me try to solve this question by myself. Sure. Fine. Listen. Basically, what they given in the question. Let's see. A single phase full bridge inverter is connected with the RLC load. First conclusion. RLC load means basically the data should be required for R. L means XL is required, then C means XC. Out of these three, they have given the value of R and XL now. The bridge operates with the periodicity of 0.2 milliseconds. Circuit turn-off time is 24 microseconds. Now, what is the expected value of C to operate this circuit in load commutation? See, first of all, let me take this resistor circuit R, inductor, and then capacitor C. We know this can be written as minus J upon omega C. This can be written as J times of omega L. This can be written as R. Yes, sir. This is the condition. Load commutation means our circuit will be in under commutation basically. Circuit will be in that is called load commutation. We are trying to operate our circuit. Under commutation means we are having 4 types of damping in control system, right? In control system, we will be talking about undamped system, underdamped system, overdamped system, critically damped system. So here our system will be operated in under damping. There only we can control everything. So system will be in under damping. That is called under damped system. So in order to bring the under damped system here, under damping means we know the value of epsilon is lies in between 0 and 1. Yes or no? First condition. So I can say the value of epsilon is less than 1. The conclusion is epsilon is going to be less than 1. Yes, sir. At the same time, in under commutation, the second conclusion is system will going to be operated at a leading power factor. In order to satisfy this condition, it should be operated at a leading power factor. Leading form factor means capacitive reactance should be dominated 1. So Xc value mandatorily should be greater than the value of XL. Now how will you calculate the value of theta phase angle, impedance phase angle? See, impedance can be written as R plus J times of XL minus XC. And you know XL can be replaced by omega L, XC can be replaced by 1 by omega C. That is fine. From this, if you are trying to estimate the value of impedance, it can be written as tan inverse of imaginary by real. Yes, sir. So this condition is true because see, here we are subtracting XL minus XC. This is correct. But here what happens is, if the value of XL is greater than XC, then this formula is true. If the value of XL is greater than XC, then the formula is true. So we can say this is for lagging power factor. Because if you observe, the subtraction is happening between XL minus XC. If you are writing like this, it means XL is greater than XC. In case of leading power factor, what happens is, we are considering only magnitude, guys. Don't consider that it is minus or positive at all. Okay. It can be rewritten as XC minus XL by R. You no need to write down all these things. Directly you can write the general expression. If you are finding the negative terms here, just to leave the negative value here. That sign is not required here. We are focusing on only magnitude. So it can be written XC minus XL for leading power factor, because I'm just telling that the value of XC is greater than XL. Sir, why should I write like this? I'm having confusion. No need to worry about it. Just write down the normal expression, substitute all the values. If you are getting negative value, just focus only on magnitude in power electronic circuits. Because positive angle, negative angle will not going to create any significance here. Here we are trying to convert this theta value into time period. So it doesn't matter whether you are having negative 30 degree or positive 30 degree. Just you have to consider 30 degree, because that negative positive will not shows that the number is negative. We know the purpose of that positive and negative here. We are using this positive and negative words just to show that the given system is in lagging or leading. It will not going to create any influence with the value of the system. That's why I am telling to consider only magnitude. Okay, fine, sir. So from this I can write tan theta equal to, if I will pass this tan inverse to the right hand side, or we can take tan on both sides. So tan theta equal to, this side will become XC minus XL by R, simply, that's all. So this is the relation between theta and XC XL R. Okay, sir. What can we do now? XL is given, R is given, XC is unknown. If we found the value of XC, then easily we can and we see, to know the value of XC we need three parameters now. XL we need, R is we need, theta also required. XL, R is already given. Now our next target is theta. How can we evaluate this theta from the given question? Let me tell you. First of all, if you observe the question carefully, the bridge is being operated with the periodicity of 0.2 millisecond. Means periodicity means what? Periodic means it is the complete time period of 360 degree. In 360 degree your system will be completing. I can't say 360 degree, I can say it is the complete time period of one cycle. After that again, after that your system will going to repeat the next cycle. Same cycle will going to be repeated. So that is the fundamental time period of the one cycle. That is called periodicity. Periodicity means same cycle will going to be repeated and the time period of the one cycle is 0.2 millisecond. That is the meaning of periodicity of 0.2 millisecond. Okay, I have clearly explained what is this periodicity meaning in signals and system. Kindly go through the lectures once. Fine, sir. So from this, fundamental time period of the cycle is given as 0.2 millisecond. From this I can easily explore the value of frequency, that will be 1 by t. So 1 by 0.2 into 10 power minus 3. We can bring this 10 power minus 3 to the numerator. It will become 1000 then upon 0.2. You can cancel it further. How will I do that? See, I am multiplying numerator by 10, denominator also 10. 0.2 into 10 will become 2. So it will become 5 times of 2 will be 10. So I am getting 5000 hertz, 5 kilohertz frequency. So we found the value of fundamental frequency here, that is 5 kilohertz. Next, 5000 hertz means that is equivalent to 5 kilohertz. So next target is how do I achieve this value of theta, sir? So here this theta basically dealing with the circuit turn off time. If you want to bring this in the load commutation வந்து நீங்க under damped system வந்து நம்ம கொண்டு வரணும் அப்படின்னா basically the condition is at least the value of omega t must be equal to theta. Impedance angle equal வந்தாதான் it is possible to bring this system under commutation. This is the basic operation of load commutation. Load commutation we have to bring the system to under damping. If you want to bring the system to under damping, then at least the mandatory minimum condition is omega t at least should be equal to theta. So minimum condition is omega t should be equal to theta at least. Okay, sir. Fine. So from this, how can I express this? Here, this theta is nothing but circuit turn off time. Are you getting me? So I'm telling this minimum time should be equal to theta, and whereas theta will be dealing with the circuit turn off time. This is the only condition in load commutation, just to remember this. And capacitor பத்தி பேசினாலே இந்த condition தான் கொடுத்திருப்பாங்க, you can just equate it. Fine, sir. Let us continue further. So I found that the value of theta equal to at least it should be equal to circuit turn off time, and omega can be further written as 2 pi f into tc. So just now we have explored the value of frequency, that is 5 kilohertz, or I can say 5000 hertz. Whereas circuit turn off time is 24 microsecond. We can directly take this 24 into micro means 10 power minus 6. And I want this theta value in degree. For that, what I am doing is I am multiplying it by 180 degree by pi. I am just transforming this value in radiant actually. See, is there any value in degree? No, all are in radiant. So I am converting into degree. So for that, how to convert a value from radian to degree. You have to multiply it by 180 by pi. Then 1 pi will get cancelled out. Yes, sir. Finally, now if I will multiply these two, 2 times of 5 will become 10. So 10,000. 10,000 into 24 will give you 24,000. Yes or no? Yes, sir. 10,000 into 24 will give you 24,000 into 10 power minus 6. So what will you do now? So 5 times of 2 will be 10. Okay, I'm having 10,000. Okay, 2,40,000. Sorry guys, I made a small mistake. It will be 2,40,000 into 180 degree. Chalo, let us continue. See, this 40 will be dealing with this one. 40 can be written as 10 power 4 into 10 power minus 6. This can be rewritten as 10 power minus 2. 24 into 10 power minus 2 will become 0.24 only. Yes or no? So here at last we have 0.24 times of 180 degree. Yes or no? So take 0.24, multiply it by 180 degree. It will be getting what? 43.2 degree. So what I am getting is 43.2 degree. That is the value of theta. We found the value of theta also. Now, what is the formula that we wrote? Tan theta equal to, at leading power factor, I am just considering magnitude. I told you already. So tan theta value is 43.2. If you take tan for this, so here I am getting tan theta equal to 0.939 equal to xc is not known minus how much xl? Xl is 10. In the question they have given. See here. R equal to 5, XL equal to 10. XL equal to 10 divided by R equal to 5. That's all. If I will reduce this expression, XC minus 10 equal to 5 times of 0.939. Just we have to multiply it by 5. Then what I am getting is, I am getting 4.695. Then pass this minus 10 to the right side, it will become plus 10. It will be 14.695. This is XC. But in the question they haven't asked a capacitive reactance. We should estimate the value of C, capacitor C. So what we have to do? Again we have to, from this, how to explore the value of XC. Xc can be replaced by 1 by omega c. So let me rewrite this. 1 by omega c equal to 14.695. This is ohm capacitive reactance. From this, I am passing C to the right side, I am bringing this term to the left hand side. Finally, C can be written as 1 upon omega into 14.695 omega. It can be further written as 2 pi f, whereas the value of f is 5000 hertz into 14.695. So this value 14.695 we have to multiply it by 5000, again we have to multiply it by 2, again we have to multiply it by pi, then we should take reciprocal for this. So here the value of C what I am getting is 2.166 microfarad, 10 power minus 6 exactly. So this is the correct expected answer for the capacitor in order to maintain the circuit under load commutation. So nothing is there to understand. Whenever we are talking about load commutation, whenever we are talking about load commutation, do remember what are the things that we have to remember. Step number one, think number one, system will be operated at under damping. So under damping means we all know the range of epsilon. It is neither 0 nor 1, but it lies in between 0 and 1. It should not be 0, it should not be 1, but its value must be less than 1, greater than 0. First thing. Second, under damping means your system must be operated at a leading power factor in order to bring the load commutation. So third one, leading power factor means capacitive reactance. Magnitude of the capacitive reactance will become greater than the value of magnitude of the inductive reactance. Under this situation, if you are trying to estimate the value of tan theta, it can be written as Xc minus XL upon R. I told you just to consider the magnitude. Such that if you remember, and one more thing is what? So the thing is, if you to keep the system in under damping in order to achieve the load commutation, the least condition to bring the system to under damping, theta must be equal to omega times of circuit turn off time. Let clearly write this. Tc denotes circuit turn off time. Tc denotes circuit turn off time. That's all. So just do remember all these points, whatever that is highlighted. So whenever we are discussing about load commutation, remember these points. Try to just solve that question. You will be getting the answer. See, this is what I have done. Already we have solved one more question, but at that time I haven't calculated this TC. But now it is explored with this value. And this is very important. This type of model is very important. People often asking by using this concept. So just do remember this. I hope you all got the clear idea about this question. Now it's time to explore the next one. Okay, let us go ahead with the next question. 1 minute, guys. So the next question is, an inverter is operated with a write down. An inverter is operated with a single pulse modulation. Okay, an inverter is operated with a pulse width modulation technique basically. And what they are trying to do is they are selecting certain pulse width to eliminate the third harmonic. Select desired pulse width to remove third harmonic. Select the desired pulse width to remove the third harmonic. Okay, and the next one is the total harmonic distortion is dash. what they are doing is, the question is what is the value of total harmonic distortion? THD is dash. There is an inverter. That inverter is operated with the pulse width modulation technique. Now what they told is we have to select some pulse width, a desired pulse width such that third harmonic is eliminated. Under this situation, what can be the expected value for total harmonic distortion? That's all. That is the given data. You can try. Just take your own time and try to bring the answer. Got the answer? Okay, you haven't got the answer. See, this is single pulse width modulation. You know the answer for this question. What is the answer? I already told you, know it will be 31 percentage. For three phase, it will be 48 percentage approximately. THD is fixed, na? Why we need to? Yes, very good, Geeta. 30.69. Good. Anyway, this answer is fixed. It doesn't matter whether you are calculating or not. This answer is fixed. That is, for single pulse, it is 31. Already we have solved the question, right? For three phase, it is 48 percentage. For single phase, it is 31 percentage. I think it is 48 only. Just to cross check once. I might be giving wrong value. Fine, sir. So this is fixed. Let us explore the next question and try to remember. Let me recapture something. What is the condition to eliminate the nth order harmonic? Listen, I just give some conclusion. How will you eliminate the nth order harmonic? We know whenever we are using pulse width modulation technique, the instantaneous output voltage can be written as, Bolo, what is the answer? Sir, it will be 4 Vs by n pi into sine n pi by 2 into sine n times of d into sine n times of omega t minus n pi. Yes or no? Yes, sir. Now here I told you this in this output voltage. Basically the harmonic elimination. How we are trying to eliminate the harmonic? Harmonic elimination technique means it is involved with the displacement angle. Which one is called a displacement angle here? D. See there. With the help of this D only, we are trying to eliminate the nth order harmonics. So basically, what we have to do is, if you want to make the third harmonic voltage, output third harmonic voltage is 0, then third harmonic voltage means the value of n equal to 3. Just example I am taking first. So what we have to do? Sine of, I am just taking our controller, only take this factor. 3 times of d. This value must be equal to 0. That is the condition. Such that what will happen? Third harmonic will be 0. If this factor will become 0, whole voltage will going to be 0. So with the help of this displacement angle, we are trying to make the value of sinusoidal waveform as 0. In general, for nth order harmonic, so for the third order, we are writing like this. Okay, sir. So how it is possible? First, from there you can say, sir, up 0 we know in place of 3D up NSR minimum expected value. You can't put 0 minimum value. Sine pi 0 see, sine will be 0 for 180 degree. If I will replace this minimum value is 180 degree. If the value of 3 times of d will become 180 degree, then third harmonic will be 0. So from this I can say d will be 180 degree by 3. So you can say at 60 degree, when the value of displacement angle d will become 60 degree, then third harmonic eliminated. Third harmonic will be eliminated. From this, you can also say the value of pulse width equal to 2 times of d. So the value of it will be 2 times of 60 degree. I can rewrite the answer is 120 degree. If I am adjusting the value of pulse width to 120 degree, then third harmonic component, effect of third harmonic component will be eliminated. That is the conclusion. So just with the help of the displacement angle only, we are utilizing this pulse width modulation technique to control the output voltage. For the nth order harmonic, this can be further written as sine of n times of d must be equal to 0, any harmonic. Then again from this I can say the value of nd must be equal to pi or 180 degree. In radian or degree, in any way you can write, that is your choice. From this I can say the value of displacement angle d can be written as pi upon n harmonic. From this I can say pulse width for the nth order harmonic is going to be what? Pulse width means 2 times of d, whereas 2 times of what is the value of d? Pi by n. So this can be further written as 2 pi by n. That is the general harmonic output expression, pulse width expression. So in order to eliminate the nth order harmonic, the pulse width must be 2 pi by n. If they are asking us, if they are talking about the fifth order harmonic, then pulse width, to eliminate the fifth order harmonic, the desired pulse width must be equal to 2 pi by n equal to 5. You know this 2 pi equal to 360 degree. You can divide it by 5. How will you divide it? It will become 7 times of 5 will be 35 degree. Remaining will be 2. So it will be 72 degree. If I will fix the pulse width as 72 degree, or this is pulse width. If pulse width equal to 72 degree, from this I can say displacement angle. How will you do that? Displacement angle equal to pulse width divided by 2. Why, sir? Because we know pulse width equal to 2 times of DC there. So from this I can say 72 degree by 2, it will be equivalent to 36 degree. So if the value of displacement angle will become 36 degree, then automatically fifth order harmonic will be eliminated. So that is how we are estimating the desired pulse width from the given expressions. Do remember these things, some of the basics. And suppose if you are requested to calculate the value of THD, total harmonic distortion, you all know the general expression, output RMS voltage minus fundamental RMS voltage. We have to square all these terms upon fundamental RMS voltage, whereas output voltage means this one. From this you can write it at n equal to 1, you can calculate the value of fundamental, whereas that is V01. How will you write down the V0R? With the pulse width modulation technique, we have written it so many times, supply voltage into 2d upon pi whole power 1 by 2. So after estimating all these values, you can easily express the value of THD. This THD can also be further written as, shall I write like this? See, V0, let me write it in the next page. This THD further written as, we know that will be V0 R square minus V0 1 square. I am breaking the denominator like this, V0 1 square minus V0 1 square. So these all terms are lying under root. Yes, it is fine, equal to. Now see, I am bringing this V0 R square to the denominator of the denominator. This can be written as 1 upon V0 square upon V0 R square minus, these things will get cancelled out. So we can write like this, all terms lies under root. Whole term. You can write the bracket like this, it will be much better. Now from here I can say, see, this can be further written as 1 upon V0 1 upon V0 R whole square minus 1 whole power 1 by 2. So from this I can say, see, what is this? V0 1 by V0 R. This is called a displacement factor. Yes or no? Now I can replace this V0 1 by V0 R by displacement factor 1 upon df minus 1 whole power 1 by 2. This is how we are bringing the relation. Suppose if the value of df is given, you can directly substitute that value and you can express the value of THD, total harmonic distortion. If the value of distortion factor is given, sorry, see, this df here denotes that is distortion factor, not displacement. Previous question we were solving about displacement angle. Now my mind is blowing with that one, so forgive me. So if you know the distortion factor, you can easily directly estimate the value of THD. Okay, that's all. I hope you all got the answer. Now let us go ahead with the next question. I hope you all understood what I was trying to mean it here. So let me give you some other data in the upcoming questions. I know some things we may not be noticed in the while solving the problems. I'm bringing those things now. See, in the next question, what they told is we are using a pulse width modulation control technique. Okay, pulse width modulation control technique we are using. They told that the frequency of triangular waveform, the frequency of triangular carrier waveform, they told that frequency of triangular carrier waveform is 20 kilohertz. First one. Next, the inverter AC frequency, the AC frequency of inverter, the AC frequency of inverter is 50 kilohertz. Now the triangular carrier waveform used to do the triangular carrier waveform. The triangular carrier waveform has peak to peak amplitude, peak to peak amplitude, peak to peak amplitude as 25 voltage. Okay, sir. Next, the control and carrier waves are shown in the figure. The question is the number of positive voltage pulses for one period of the inverter. The number of positive voltage pulse, the number of positive voltage pulses for one period of the inverter is dash. One period of the inverter is dash. That is the question. Now we have to estimate this value. Sir, how should I do this? Let's take some time. First understand, they have given some waveform. I will be bringing it here. Given it is, they are considering a triangular waveform. It is going like this. From here they have given the reference voltage and this one is going to be carrier voltage. So both they given with respect to omega t. Listen, peak to peak 25 voltage means, what is this? Peak to peak means this is maximum peak, this is minimum peak. அப்போ நீங்க என்ன பண்ணீங்க 2 ஆல டிவைட் பண்ணனும். 25 by 2 will be 12.5. So 12.5 in negative zone it will be minus 12.5. Now what is the difference? This is called peak to peak. Peak to peak. Okay, total will be 25. So they are going between 12.5 to minus 12.5. This is given. Now the question is, we have to identify the number of positive voltage pulses for the given period, over the period, right? So let me tell you the direct formula just to remember these things. Whenever they are asking you to identify the number of pulses, the formula is n equal to generalized formula. You can write carrier frequency upon 2 times of reference frequency. Some of you might know these things, just to have a hint. Okay. Number of positive pulses equal to carrier frequency divided by 2 times of reference frequency. Everything is given in the question. See, triangular carrier frequency is already given as 20 kilohertz. So 20 into 10 power 3 upon 2 times of reference frequency also given, that is AC inverter frequency. They told that is 1 minute. It should not be 50 kilohertz. It is supply voltage, right? Guys, wait a minute. They made some mistake. It should not be, yes. See, supply voltage should not be 50 kilohertz. It is 50 hertz. Our system fundamental frequency. It is 50 hertz, just 50. Now see there, 1 0 will get cancelled. This 2 also will get cancelled. So totally we have 1000 by 5. Or we can say it will be 200. So totally we are having 200 pulses over one period of the inverter. That's all. That is number of pulses. Just to remember this formula, that's why I have written here. I told you that I'm bringing something new, just to, I know it might not be covered here, even in our lectures also. Some things they are related to IAS questions. You can just keep a note, because in some state government exams also you can expect this type of questions. Okay, fine sir. I hope you understood how to deal with this kind of things. Fine. Now let me bring the next question. The next question is, in a sinusoidal pulse with the modulation technique, the order of the harmonics, the order of the harmonics dash. How will you write down the order of the harmonics? With the help of in a sinusoidal pulse with modulation inverter, order of the harmonics will be in the form of dash. That is the question. Order of the harmonics in the form of dash. Sir, how should I write down this? Order of the harmonics. Anybody knows? It is very simple. Let me tell you. Actually, the order of the output harmonic is associated with 2n plus or minus 1. If I will replace n equal to 1, then what we will be getting? 2 plus 1 will be equal to 3. 2 minus 1 will be equal to 1. So this is the fundamental frequency. This is third harmonic. Even harmonics will be eliminated. I told you we are not considering it effect. Suppose if the value of n equal to 2, then 2 into 2 will become 4 plus 1, 4 minus 1. Again see there, 4 plus 1 means fifth order harmonic, 4 minus 1 means third order. So basically this generalized formula is dealing with the only hard harmonics. Hard harmonics. Yes or no? Yes, even harmonics are themselves, they are 0 here, so we are not considering that effect. That's all. Just do remember this. That is sufficient. So here I hope I had given all type of questions which are related to our systems, right? So now it's time to explore some of the questions which is relevant to our three-phase system, right? So for that we will be going up with the gate questions only, because from the three-phase inverter there are no huge number of questions in any exam. Basically from inverters most of the questions will be asked from pulse width modulation technique and single phase full bridge inverter only. That's why we have been involved so far with the single phase full bridge inverters and its pulse width modulation technique, because most of the questions will be directly asked from that area. So it is very important to remember those things. Not remember, practice as much question as possible by yourself. As many questions. Sorry. 1 minute, I'm just taking that. Okay. So let us consider some of the three-phase system and try to bring the answer for those questions which are asked in our previous year gates. So the first question is, let us take a three-phase voltage source inverter. A three-phase voltage source inverter with the ideal devices operating at a 180-degree mode of conduction. Operating at a 180-degree mode of conduction. 180-degree mode of conduction. Yes, operating at a 180-degree mode of conduction. Fine, sir. Now, it is connected with the balanced three-phase star connected load. It is connected with the balanced three-phase star connected load. Balanced three-phase star connected load. That is given. Fine, sir. And load is resistive load, purely. Load is purely resistive load. Now the question is, the supply voltage is Vs. Supply voltage is Vs. Then the peak of the fundamental component of the phase voltage is dash. See, the supply voltage Vs is given, that is 200 voltage. Now the question is, the peak of the fundamental component of the phase voltage is dash. The peak of the fundamental component, the peak of the fundamental component, peak of the fundamental component of the phase voltage is dash. So you can drop your answer. In three-phase questions will be direct questions. If you remember the formulas, you can drop your answer. Take your time. Try to bring the answer. So given it is 180-degree mode of conduction, right? Got the answer? $127.38. Very good. Any other? Any other? No answers. problem. Let me try to bring the answer. Listen, I told you that is direct question, right? Fine, sir. Tell me, what is the expression for 180 degree mode of conduction and 120 degree mode of conduction? How will you explore all the values? So when we are entering into three-phase system, first, when we are considering 180-degree mode of conduction, here most of you guys are having some doubts here, right? See, basically while dealing with the three-phase system, we will be having two type of conduction. One is 180-degree mode of conduction, another one is 120-degree mode of conduction. It doesn't matter whether you are in 120-degree mode of conduction or 180-degree mode of conduction, the effect of third harmonic will be eliminated in both of these. But sometimes what they are asking in your question is, they are talking between the leg and the supply voltages. What is this, sir? When we are designing the three-phase system, you might be remember, we will be connecting the supply voltage legs with the switches like this. So they will be talking about leg to phase voltage. Under this situation, you people are confusing with this under conduction. So basically, in both 120-degree mode of conduction and 180-degree mode of conduction, the effect of third harmonic voltage will become zero. This third harmonic voltage will exist between the legs and phases. There you can observe the third harmonic effect. There is a difference between these two. Don't get confused. When they are talking about phase voltage, line voltage, 180-degree mode of conduction, 120-degree mode of conduction, no need to think your answer will become zero only. When they are talking about, when this word is appearing, leg means between this point and this point they are trying to measure the voltage. That point, in under this situation only, that voltage will appear. Do remember this, okay? Don't blindly make mistakes. Fine, sir. In 180-degree mode of conduction, how will you write down the line voltage expression, phase voltage expression? So you all know line voltage. Line voltage can be expressed as summation 4 VDC as usual, right? 4 VDC by n pi into cos of n pi by 6 into sine n times of omega t plus n times of pi by 6. That 30-degree relation between line and phase voltages, right? Similarly, if you want to write the expression for phase voltages, how will you write? Phase voltage can be written as in the same way. That can be written as 2 VDC by n pi. You know the relation between line and phase in case of star connection. Line voltage equal to root 3 times of phase voltage. That's all. Do remember this. If you know line, you can bring phase. If you know phase, you can bring line voltage. So it will become 2 VDC by n pi into sine n omega t. Simply, that's all. This is for 180-degree mode of conduction. In your question, they are talking about 180-degree mode of conduction only. What they are asking you, the peak of the fundamental component of the phase voltage. See, this is the phase voltage of the 180-degree mode of conduction. And what is the peak voltage? This is peak voltage. So 2 VDC by n pi is the nth order peak voltage. For the fundamental, I have to replace n equal to 1 such that this expression can be rewritten as 2 VDC by pi. Whereas the value of VDC is clearly given in the question, that is 200. So 400 by pi. 2 into 200 will be, 2 times of 200 will be 400 only. No? So if you divide by 400 by pi, you will be getting 127.323 volts. This is the correct answer. This is for 180-degree mode of conduction. Sir, suppose if I will be considering 120-degree mode of conduction. What is the expression for phase voltage and line voltage? Again, line voltage can be simply written as summation of 3 times of VDC by n pi into sine n times of omega t, and if you are evaluating the phase voltage V phase of t, summation that is going to be 2 VDC by n pi into cos of n pi by 6 into sine n omega, sorry, sine n omega t plus n pi by 6. That's all. So just do remember the expressions for line and phase voltages. That is very important. Okay, sir. This is the fundamental. I think, sorry. This is in terms of trigonometric Fourier series expansion. Now we will be writing one more form directly. If a waveform is given from the waveform, how will you calculate the output voltage? So the output phase voltage for 180-degree mode of conduction. Again, we will be taking with 180 general expression. It is not in terms of trigonometric Fourier series expansion. Just we have the input voltage and what can be the expected output voltage. That is going to be supply voltage into root 2 by 3. This is V0 phase voltage. If you take V0 line voltage, sir, I am writing only RMS components, RMS voltages. So this will become supply voltage into, I think it will be 2 by 3 whole power 1 by 2. So from this, if you people are asking exam on the power consumed by the load, it will be 3 times of phase voltage, right? So V0 phase RMS voltage square by R. Remember, this is phase voltage. Okay, fine, sir. So now, suppose if you are considering 120-degree mode of conduction, what can be the generalized output voltage? This is not in terms of trigonometric Fourier series expansion. I'm just talking about the from the output waveform. If we are trying to calculate the RMS voltage for the output waveform, how you what value you will be getting? Okay, that output voltage only further expanded in terms of harmonics plus fundamental with the help of trigonometric Fourier expansion. Okay, so this V naught equal to simply what we can say is this is 120-degree, right? So if you are considering phase voltage, it will be supply voltage upon square root of root 6. It should be, yes, I'm correct. So similarly, it will be if you are going up with the RMS line voltage will be equal to VDC by root 2, square root of 2. That's all. So this is how we are calculating the voltages and power. If they are asking the output power, this can be further again written as phase voltage square by R and 3 times. So that is going to be output power. Okay. Rest of things I hope you all know, right? That's all. So in three-phase system, questions will not be asked. Any indirect questions will not come. Most of the cases they will be giving the direct questions. But if you don't remember these expressions, it is a little bit tough situation for you all, because at least we have to remember this fundamental basics. See, let me bring the next question. See, a three-phase voltage source inverter is supplied from 600 voltage DC. Supply voltage they have given 600 voltage DC. Now the question is, as usual, output is star connected. Output is star connected or load, resistive load, star connected resistive load, whereas the value of resistance in each phase is 20 ohm per phase. It is each phase 20 ohm per phase, it is given. Now the question is the at 120-degree mode of conduction, 120-degree mode of conduction, the output power is dash. That's all. Are you understanding this? Supply voltage is given, output is star connected resistive load, whereas the value of resistance is 20 ohm per phase. It is star connected balanced load. It means in all phases we will be having same value, 20 ohm per phase only. Now the question is, what is the output power in case of 120-degree mode of conduction? Can you please do it? Take your time, bring the answer. It's a simple one more question. Just now I have derived all formulas. Don't need to think too much. Just drop your answer. Very good, Geeta. 9 kilowatt. Very good. Very good. Any others? It's a direct question, yeah. Chitra 9. Good. See, I have written all the formulas just now. For 120, 180, how to calculate the output power. Okay. I think this much of time is not required for this question, right? என்ன கொடுத்துருக்காங்க சப்ளை வோல்டேஜ் வந்து 600 120 டிகிரி மோட் ஆஃப் கண்டக்ஷன் ஒன்றுமே கிடையாது அவுட்புட் வோல்டேஜ் சி வெயிட் அவுட்புட் பவருக்கு ஃபார்முலா என்ன இப்போ தான் பார்த்தோம் நம்ம அவுட்புட் பவர் கேன் பி ரிட்டன் as 3 times ஆஃப் அவுட்புட் RMS வோல்டேஜ் ஸ்கொயர் டிவைடட் பை R. தட்ஸ் ஆல். அவுட்புட் RMS ஃபேஸ் வோல்டேஜ் ஃபார்முலா என்ன VDC by root 6 whole square by R. Yes or no? Just now I wrote this. Where is that? See, 120 degree mode of conduction, phase voltage. But I told you I am writing the expressions for RMS only. So these all are RMS. Just to substitute 3 into input voltage, supply voltage is 600. VDC means that is supply voltage only, VS. 600 by root 6 whole square by resistance, that is resistance per phase, right? 20 ohm. Substitute this, you will get the answer. What is this? It will become 3 into 6 square, it will become 36,000. Sorry, 3,60,000, right? 6 square na 36, it will become 10,000. So denominator root 6 whole square will become 6. Already one more 20 is there. Now it's time to reduce this. It will be 6 times. Yes, sir. 1 0 will get cancelled. It will be 3 times. 3 times of 3 will be 9. So it will be 9,000 watts, or it is 9 kilowatts. That is the total output power consumed by the load, balanced load. That's all. See how easy it is. Gauri, very good. That's all. So we have happily completed our system, what I can say, power electronic circuits. See, there are some portions in which we have, I may not found any questions here, but here I have covered only the areas in which we people are struggling a lot. It doesn't matter only from this area questions will come. Apart from this, there are few more other areas. There is one more inverter is called auto sequential commutated inverter. Do you remember? Auto sequential commutated inverter. If you observe the auto sequential commutated inverter, the question often it will be asking you is to calculate the value of minimum circuit turn off time. So the minimum time taken by the circuit is that will be 4 times of RC. Everything is available in our short notes. I told you that that was made. I made this after my experience only. So I have covered almost 90% of the things which are very important or which will not be stored in our mind. So the maximum frequency, if they will ask you, just to take reciprocal for this 1 upon 4 RC. Okay. So do remember these formulas. That is very important. Fine, sir. And also the modulation technique, everything we have covered. So with this, our power electronic circuits are completely over, right? So in the next class, we will be starting up with the new subject. So till then, don't stop your preparation. Like stop your preparation means try to solve as many questions